Hey guys, welcome back to my channel. Well, if you're just joining us for the first time, we're still looking at cam profile, but today will be a knife edge with an offset. Okay, so please endeavor to subscribe to my channel and give the video a thumbs up. Alright, the cam is to give the following motion to a knife edge follower when the outstroke and return stroke is 70 degree and 120 degree respectively of the cam rotation. The stroke of the follower 40mm and the minimum radius of the cam is 30mm. The follower moves with uniform velocity during both strokes. Draw the cam profile when the axis of the follower is offset by 10mm of the camshaft axis. So the first thing I'll do is to write out the parameters. So we have outstroke given to be 70 degrees, return stroke given to be 130 degrees. Okay. What else we're given the question? We're also given that the dual is equal to 40 degrees and the remaining part is 120 degrees of this cam motion. Alright. Then we're also given that the lift is 40mm and we're given that the cam radius is 30mm and the outstroke is in uniform velocity and return stroke in uniform velocity. Those two are the same motion for both outstroke and return stroke, and it was offset by 10mm. So let us draw. So with the cam radius 30, I'm measure 30 with my compass and I'll draw a circle of radius of 30mm. Alright, having done that circle, I'll also measure the offset circle, which is radius of 10mm as 1 cm, pin at the circle center there and draw the offset circle with radius of 10. Now I will have to draw a horizontal line from the middle point to touch the offset circle from the center, okay? And then draw a perpendicular line from this point here, straight, to touch the base circle, that's the cam radius. At this point here, that's actually where we'll start measuring our lift. And our lift was given to be 40mm. So I'll measure 40mm from that point there, okay, from that point, 40. So I'll pin at the circle center there, elongate to that point that I drew for the lift and draw a circle. Now everything I'm doing will fall within this big circle. Okay, so having done that, I'll start going my motion. I'll first go with outstroke. Okay, outstroke is 70, so I'm just 70 from my right. 1 2 3 4 5 7, that's 70. Okay, then I'll place it on that 70 line, put the center at the center, put the center and then do the dual. You know, it's outstroke, dual and return stroke. Okay, the dual is 40 as a dual, that's 40. Make sure that your line only falls within the offset circle, and then the return stroke, which is 130. So I'll put it at my 40 line, I mean to say 130 for the return stroke. So having done this, remember I told you we're dividing every motion into 6. That's we're doing that return stroke side, the outstroke into 6, return stroke to 6. Dual is not a motion, so we'll leave dual undivided. So if you do 70 divided by 6, that's 70 degree divided by 6, and we're having 11.6, that's approximately 12. If we do that 130 divided by 6, I'm having 21.6, that's approximately 22 degrees. So I'm going for that return, for that outstroke, I'll be going 12 degrees each. So from 0 to 12, 24, 36, 48, like that till you get to the end. Okay, all right. The time will permit me to show the full details, but I'll show you the end results. All right, so this actually look like when you divide into 6 square parts. It's very tiny. Okay, all right, so you go skip that dual part because dual there's no motion there. Get to the return stroke part. Okay, I want to go for my left because the protractor was calibrated 0 from this my left, so I'm going 22 44 68, like that. Just keep going in 22 degrees, add 22 to it, and then be going like that, then go that 6 times. Okay, oh sorry, I actually made a mistake. Okay, I actually made a mistake in this part, sorry, but I've just corrected it. Just go with 22 degrees each. All right, and then you join the point on the offset circle. Okay, all right, now we're getting to the most critical part of this, where we'll draw perpendicular to all this line. Let me make this video more bold so I can actually see it clearer. All right, so I place it on my first line, place my ruler. Okay, do the first one, place it, I seen it. I'll do it on the second line, place my ruler there on it, and then do the second one. All right, So I'll do it. You see, place it now on the third line now. Okay, and then do it for the third point, fourth one. Just keep going. So you are drawing this perpendicular for all the points. The fifth one, then the sixth one. Once you get to that beginning of the dual side, you stop. Okay, remember I told you that dual is, I would like put this on a constant motion, so we're not dividing it into any parts. You only divide move, like parts that are moving, like divide motion into six-equal parts. Okay, all right, so I'll do the same thing to having done for that outstroke. I'll do the same thing too for the return stroke. Okay, so I'm basically doing the same thing for the return stroke part. Alright.
You're welcome.
Okay, so I'll number it 1 2 3 4 5 6, then 6 5 4 3 2 1 0. Okay, remember that dual part is 6 and 6 because it's constant motion, nothing is changing. So for the lift, now lift is 40. Remember, lift is having a motion too because it's going to and from. I'm dividing that lift into 6 equal parts. If I do 45/7, I'll be having 6.7, approximately 7. So I'll be going 0.7, 0.7, 0.7 upward. Okay, but I have to get the half so that I'll just give it equal measurement. You know, we're doing realizing approximation so that you will not be having different things. Alright, so our number is 1 2 3 4 5 6. Alright, remember how we do our cam profile stuff? I'll pin at the center point here and then do 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5, and less. And that's what we did. So at the end, we then joined all the points together with our French curve. Okay, so this is actually how it looks like. This is actually the end product. We're not actually done. Something's actually missing. Let's signify that this is a knife edge follower. Okay, let's draw the knife edge gongo. Actually, one what is gongo. Gongo is actually I would like exclamation in our tongue here. Alright, thank you for watching our video today. See you guys in our next episode.